Okay, let's dive into the fascinating world of watersheds and runoff. This is a crucial topic for anyone interested in environmental science, hydrology, or just understanding how water moves through our landscapes. If you've ever wondered how scientists calculate the total water runoff from a watershed, you're in the right place. This process is essential for managing water resources, predicting floods, and even planning urban development. Today, I'm going to explain how to use integration to figure this out. Don't worry if you're not a math whiz. We'll break it down step by step. First, let's get our basics down. So, what's a watershed? Understanding this concept is the foundation for everything else. A watershed is an area of land where all the water under it or draining off of it goes into the same place. Think of it as a giant funnel. This funnel collects all the precipitation and channels it into a single point, like a river, lake, or ocean. When it rains, water from the watershed will flow into a river, lake, or ocean. This movement of water is what we call runoff. Now, when we talk about surface runoff, we're looking at the water flow that occurs when the soil is saturated and excess water flows over the ground. This is a key factor in understanding how much water actually makes it to our rivers and lakes. This is crucial for understanding water volumes because not all rainwater soaks into the ground. Some of it runs off the surface, especially during heavy rains or when the ground is already saturated. Some of it runs off the surface, contributing to rivers and lakes. This surface runoff is what we need to measure to understand the total water flow in a watershed. Okay, on to the good stuff, cumulative volume. This is where things get a bit more technical, but also more interesting. This is the total amount of water runoff over a specific period. It's like adding up all the water that flows out of the watershed over time. To find this total volume, we need to use a bit of math, specifically integration. Integration helps us sum up small amounts of water flow over time to get a total volume. Imagine you have a graph showing the rate of runoff over time. This graph is crucial for our calculations. The x-axis represents time and the y-axis represents the rate of runoff. By looking at this graph, we can see how the runoff rate changes over time. Integration helps us find the area under this curve, which gives us the cumulative volume of water runoff. This area represents the total water that has flowed out of the watershed over the time period we're looking at. Here's the integration formula we use, RT dt. This formula might look complex, but it's just a way to add up all the small amounts of runoff over time, where RT is the runoff rate as a function of time, and dt represents a tiny slice of time. By summing up these tiny slices, we get the total volume. By summing up these tiny slices, integration calculates the total cumulative volume. It's like adding up all the small pieces to get the whole picture. Think of it like adding up the area of numerous tiny rectangles under the curve. Each rectangle represents a small amount of runoff over a short period of time. The more tiny rectangles you add, the more accurate your total volume calculation becomes. This is why integration is such a powerful tool in hydrology. Let's go through an example calculation. Suppose we have a runoff rate RT equals 2t plus 3, where t is time in hours. To find the total runoff over a 5-hour period, we need to integrate this function from t equals 0 to t equals 5. The integral of RT from 0 to 5 is 2t plus 3 dt from 0 to 5. Solving this, we get t squared plus 3t from 0 to 5, which equals 25 plus 15, 0 plus 0 equals 40. So the total water runoff over the 5-hour period is 40 cubic units. This example shows how integration helps us calculate the cumulative volume of runoff. And there you have it. By understanding the watershed surface runoff and how to use integration, you can calculate the total water runoff from any given watershed. By understanding the watershed surface runoff and how to use integration, you can calculate the total water runoff from any given watershed. This knowledge is invaluable for managing water resources and protecting our environment. It's a powerful tool for hydrologists and environmental scientists. Thanks for watching. We hope you found this explanation helpful and enlightening. Don't forget to like, share, and subscribe for more easy-to-understand explanations. Stay curious and keep exploring the wonders of our natural world.